Hi everyone, and welcome to another part of the Solidity tutorials. In this part we're going to deploy and test the contract that we have previously written. So this is again one of the bonding curve smart contracts for creating a token which is ERC20, and we would follow a pattern for pricing. So as you can remember, the pattern of pricing we used to follow a formula. We would integrate it and use the integration formula in here, and also we added this dollar to way conversion here, which we previously worked on with the price conversion algorithm from the price conversion.sol. So we tested that contract and bought that here, but this one is dollar to way instead of way to dollar. And the reason we did this was that we wanted this formula to be in the unit of dollars. So for example, if we want to buy a token, that token starts from $100, and then it would increase to 101, 104, 109, 116, 125, and so on and so forth. So we would use this formula, but it used to be for the unit way or Ethereum. So we want this to be in the dollar amount, right? So the thing we do here is that we convert it to dollar and then use it right over here. So we want to deploy and test this contract to see if it works very well. So first of all, we need to run this aggregator.sol. So the reason we do this is to get the price feed from this contract, copy the address and paste it as a price feed in the constructor here. So if I save this contract and go over here, you will see that we need an address for the price feed. So first of all, we need to run the aggregator.sol or deploy this. So let's find the mock price feed. Notice that we've got an interface which cannot be deployed. So we need to find this, and we'll check the price right now. Ethereum pair with USD, so you can just copy the price and paste it right over here. So it's 1918, and so click transact. So it's been done. Now all we need to do is to copy the address and head over to the other contract that we have. So let me switch to that, and here we should choose the integral bonding curve for dollar. Here we go, and then we'll have the string, so I can name it again my token MTKN for the token, and the price feed, which we have the address for it. So we can just paste the address and click transact. So now open up the instance of a contract that has been deployed, integral bonding curve. So once you open it up, you will see that we have the same options here. So right now what we need to do is, because the prices are in dollar, so the prices will be higher, right? So $1 will be much more amount of way than what we had here. So previously we would enter, for example, 2,000 ways and we would buy 7 tokens, but right now we should buy a greater amount. So for example, here I enter 1,000 Finny or 1 Ethereum, 1 Ether. So enter 1 Ether and buy, for example, 7 token again. But notice that some of the a high proportion of the price will be gotten back to me, because we have this payable message.sender, and we will calculate the difference of the message.value that we enter here and the ETH amount. So it will calculate the ETH amount and would pay back me the remaining of the price. So here I will enter 7 to buy the token, and as you can see, it's been successful. And let's take a look at here. As you can see, not accurately 1 ETH has been, this should be 98 point some number, but now it's 99.15, which shows that I've been paid back the price, the remaining the money that I have entered here, right? And it has calculated the amount that this contract has got. So it's 0.42 Ether for 7 tokens, right? Which makes sense because it's just about if we calculate the integral, it's just about $1,000, and it's probably half in Ethereum, right? Because this is the price of Ethereum, 1,900. So it's nearly half of the price in Ethereum, which makes sense right over here, right? So now we can get the price in dollar. If you click on the get price in dollar, it's 149. So the next token that you buy is this price, right? So it's not in VAY anymore, and it makes more sense, right? Because no token would worth that little amount of money. So, but in dollar, it's more realistic than the in VAYs, right? So here you can see how much you've been paid back, how much the contract has been paid, and also here you don't need to enter any specific amount for the contract, right? So you don't have to also write the receive and fallback in order to fund the contract. So now let's sell the tokens. So once we want to sell the tokens, we can enter 7 and sell the tokens. As you can see, the supply comes back to 0, and the current price will go back to 100. So anyway, this contract, it shows that this contract works very well, and everything is just as we wanted. So, and also if you're writing this for testnet or mainnet, I repeat this because this is really important. If you want to pay less gas fees for buying and selling the tokens, you should reduce the number of functions. So you might need to write most of the codes in one function. So whenever you want to, for example, buy the token, it uses this function, calculate ETH amount, and also integrate, and also dollar to VAY. So there are 4 functions that we are using, but they can be reduced to 1 or 2 functions to pay less gas fees. But here, for clean coding and for educational purposes, for you to better understand what's going on, I'm writing the functions like this, but for it to be more optimized, we have a trade-off, and in order to do so, you need to actually make all the functions into one. Also for the sell token, so whenever you want to sell the token, we'll calculate if and integrate, and then calculate dollar to VAY. So 4 functions are used. You can just boil them down to 1 function, right? And another consideration is that we use the actual aggregator v3 interface to get the exact price, and so that you don't need to update the aggregator.sol, because in this few minutes that we've talked and tested this contract, the price of Ethereum has changed, right? Actually, it hasn't changed, but it might change rapidly. So this is not a standard way of a smart contract to work, because the price that we've entered it belongs to just about a few minutes ago, but it needs to be updated over and over again in shorter timestamps. So in order to make this updated all the time, you need to use the v3 aggregator v3 interface .sol, and that one will update the price over and over again, and you don't have to run this aggregator.sol by yourself and enter a price fit, right? So it doesn't happen like that, and it doesn't work that way, but this is just for testing purposes, okay? So we do not generally do this, but because this is Remix ID and this is for testing the contract in a much quicker way than just writing it and deploying it and compiling the contract, deploying it, and running the functions, interacting with the smart contract. Here on Remix ID, you can test your smart contracts in a much better way. So first of all, after all of these smart contracts, I'm going to end this part of our tutorial related to Solidity. So we've learned a lot of smart contracts up to now, and so we will use all of these smart contracts later. We will enhance these smart contracts and use them on a more real world places, such as the test nets, local nets, and once you learn how to work with test nets, you will then be able to work with the mainnet, because they're exactly the same, but the networks are a little bit different, but the process is the same as the test net. But before we do that, we will also work with local net, Ganache, and also Ganache CLI. So in the next set of tutorials in the next course, we will get out of the Remix IDE. However, we might use the Remix IDE for testing out contracts quickly and then taking them to VS Code so that you can better compile it. We'll compile it in the real world, and you will understand that getting outside of Remix IDE, deploying, compiling, and testing the contract takes much more time, but it's the standard way in which we use the smart contracts, because as you can see here, we have a lot of limitations, such as this one in the aggregator.sol or NFTs, if you can remember. But once we get into the real world applications with VS Code, and we work with some of the libraries such as web3.js, or once we work with Python, web3.py, and we work with the frameworks such as Truffle, Brownie, Hardhat, and so on, you will learn how to easier compile the contracts and work in a much better environment that is more realistic, and then you will be able to write your own, create your own dApps, and actually create your own actual token, and be able to see that on Etherscan and the testnets of Etherscan. Okay, that's it for this tutorial, and also that's it for this course. So I'll see you in the next courses, and we will continue our journey, but the course related to the Solidity smart contracts on Remix IDE has ended. Notice that we will continue our journey in the smart contracts in the next courses as well. And finishing this tutorial does not mean that we are done yet with these smart contracts. There will be a lot of other smart contracts, or we might use these smart contracts and enhance them and use them inside of our dApps. So until the next course and the next set of videos, goodbye.